So in the last video we estimated the instantaneous velocity of the diver as he was 1 second into the air, and we measured that as negative. So I messed up in the last video. I didn't put my negative, but as you can tell, all these values are negative in the table. So it was negative 16 feet per second. Now we're going to do it using calculus, using the definition of derivative. So the definition of derivative has a specific formula. So it's f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. But instead of using f of x, since we don't have f of x, we have s of t. We're going to go ahead and replace all these f's and x's with s and then t's. S of t plus h, s of t. Okay, so here's what we need to do. We need to define what s of t plus h is. Well, we have the function s. It's negative 16t squared plus 16t plus 32. Now for every t, I'm going to plug in a t plus h. So it's negative 16t plus h squared plus 16t plus h plus 32. So it's really just the same function, except now for every t is a t plus h. Well, simplifying this becomes s of t, and then doing the FOIL will give 2th plus h squared plus 16t. Distributing the 16 will give me 16t plus 16h, and then plus 32. And then I'm going to go ahead and distribute the negative 16. Negative 16 t squared minus 32 th minus 16h squared plus 16t. Here I forgot an h, that's my fault. 16h plus 32. Okay, so as you can tell, none of these numbers combined, they are all unique. They don't have a common variable, so I can't combine terms. So all this is going to be my s of t plus h. So rewriting s prime of t, the limit as h approaches 0 of all of this stuff here. So the top part's going to be negative 16t squared minus 32th minus 16h squared plus 16t, 16t plus 16h plus 32. Now, that's only the s of t plus h part. So let me go ahead and move this down because I need more space. Okay, so continuing the fraction. So that is the s of t part. So that is only this part right here. Now I got to do the subtraction of s of t. So, and that is the original equation. But when I negate the equation, I also negate the signs. So it's going to be plus 16t squared minus 16t minus 32 all over h. And then I notice that I have some terms that may cancel. So I have in common a negative 16t squared, a positive 16t squared, minus 16t, positive 16t, positive 32, negative 32. All of these terms that I just highlighted, they go away. So rewriting the limit. So the limit as h approaches 0 of negative 32th minus 16h squared plus 16h all over h. Now, In the top, I have a common factor of h. I can factor it out and cancel it with this one at the bottom. Or if you already understand that you can cancel one h at a time, you can just rewrite your limit. This h still survives since it was squared, and now we have this limit. And now I can apply the limit for every h and not get a 0 or 0. So 32t plus 16 is my s prime of t. It's my derivative of the position, which will yield velocity. Now, we're interested in finding when the instantaneous velocity is t equals 1. At t equals 1. So I can simply just plug in t equals 1 in here, and I get negative 32 minus plus 16, and my velocity answer, my instantaneous velocity, is negative 16 feet per second, which is what we estimated in the last video. So we derived the instantaneous velocity by using calculus to find that. Okay, and we can also use the alternate form of definition of derivative to get the same answer. So the alternate form is s prime of t. Well, now it's s prime of c, because the alternate form definition of derivative gives you a numeric value. It is the s of c minus, no, it's s of t minus s of c, t minus c. Okay, just to double check, let me go ahead and go back over here. Yes, okay. And I forgot the most important part is the limit as t approaches c. Okay, so let's use this. So the limit as t approaches c. Well, this time we're actually doing 1, since we want to find out the instantaneous velocity at 1. So it's going to be s of t, which we said it was negative 16t squared plus 16t plus 32 minus s of 1, which we already know is 32, all over t minus 1. So every c became a 1. So those cancel. And then we are left with a the limit as t approaches 1 of 16t squared plus 16t all over t minus 1. Now the top part can factor. I can factor out a negative 16. I can factor out a negative 16, which will give me a t minus 1 on the top. Well, I can actually factor out a negative 16t, so that's my fault. Negative 16t can be factored out. So now I have a 16t times t minus 1 over t minus 1. Those cancel. Now I have the limit as t approaches 1 of negative 16t. I can apply the limit here, and it's negative 16. So that actually required a lot less work. Now, the only thing is that this alternate form sometimes may not be the best approach. So you would have to revert back to the definition, the regular definition. Okay, and last but not least, since you found the derivative at t equals 1, since the derivative means slope, let's go ahead and find the equation of the tangent line that passes through s of t at t equals 1. So what do you need for an equation of a line? Well, you need a slope. It's your m. And you also need a point. And when you have a slope and a point, you simply use point slope formula. Okay, so we have a t value. Okay, I have the t value, but I don't have the y value. This is missing. So we simply just find the value at 1, and we already know it's 32. So this is 32. Okay, so now we have the point, now we have the slope. The slope, remember, if you know what slope was, it was the instantaneous rate of change. M was equal to -16. Now using the point slope formula, we have y minus 32 is equal to -16, x minus 1. And that is our final answer. In calculus, you do not need to simplify. You can leave your answers in point slope formula, and the AP reader will still give you full credit.